Math 043, solving system of linear equations. In this video, I am only going to solve by graphing. Essentially, what we are going to do is we are going to graph two lines on the same grid, and where they intersect will be the answer. Keep in mind, all answers will be ordered pairs, and ordered pairs need to be written correctly. But we will start off with example 1. Is 1, -10 a solution to the system? So we will substitute in 1 for x and -10 for y. And if the ordered pair makes both equations true, then we will say yes. If one of the equations is not true, then the ordered pair is not a solution. And clearly we can see that -15 does not equal 4. Therefore, 1 -10 is not a solution. Number 2. Again, we will substitute in -2 for x and 7 for y. So I'm basically solving the left side, and I get -16, and it is equal to the right side. So that's works for that equation. So it works in both of them. So you must state that yes, it's a solution. So the first method of solving a system of equations is by graphing. So we have two equations, y equals -3x plus 8. So I'm going to graph that equation. I will go to 8 and put a dot. And the slope is -3. So I will go down 3 and write 1. And then I will connect the dots. And now I'll graph the line y is equal to -x. The y-intercept is 0, 0. The slope is -1. So I will go down 1 over 1. And once the lines intersect, I can draw my line. And the answer to where the system intersects is the ordered pair for -4. Your graph is your work. Your answer is the ordered pair. Example number 2. Graph each of these lines. So the first one I'm going to solve for y. I'm going to put in slope-intercept form. So I know the y-intercept is 0, -4. And the slope is -2. y equals 4x plus 8 is already in slope-intercept form. The y-intercept is 0, 8. The slope is 4. So go to 0, 8 and put a dot. Clearly, I cannot go up and to the right because I don't have enough space. So I'll make them both negative and go down and to the left. And the lines intersect at the ordered pair -2, 0. I can check this to make sure it works by substituting in -2, 0 in both equations, and they will be true. I'm going to solve the first equation for y, so I'll put it in slope-intercept form so that the y-intercept is 0, 2. And the slope is 1/2. So go over 0, up 2, and put a dot. And then graph the slope by going up 1, right 2. I can also go down 1, left 2. I'm going to put the second equation in slope-intercept form as well. So subtract 2x from both sides. Divide everything by -4. Simplify, y is equal to 1/2 x minus 3. The y-intercept is 0, -3. And the slope is 1/2. And since they have the same slope and different y-intercepts, they are never going to touch. The lines are parallel. Therefore, we say the system has no solution. I'm going to put the first equation in slope-intercept form by subtracting x from both sides, dividing everything by -1. The y-intercept is 0, 3, and the slope is 1. So I go up 1 over 1, up 1 over 1. Well, I notice that the second equation is the same as the first. The y-intercept is 0, 3, and the slope is 1. So these two lines are the same. So in this case, they have infinite many solutions. Or you can use the infinity sign. So there is some vocabulary that you need to know. And it's how we classify linear or classifying systems of linear equations. So we say a system is consistent if it has a solution. So in the first column here, we have one solution. And exactly one solution we describe as consistent and independent. There is a solution and there's one solution. If the system has infinite many solutions, there is a solution, but since there are infinite many, we say that the system is consistent and dependent. Consistent and independent, one solution. Consistent and dependent, infinite many solutions. If the two lines are parallel, then we say the system is inconsistent. So we can go back and we can classify every system that we've just graphed. So for example, 1 has one solution. So we can classify this as consistent and independent. Example 2 would be the same. It would be consistent However, example 3, the lines are parallel, so there is no solution. If there's no solutions, then the line is inconsistent. And in example 4, we have a solution, and it's infinite many solutions. So we say it is consistent and dependent. And there you have it.